All right. Ionic bonding. The ionic bonding is always going to result in a compound. We define compounds as when two or more elements chemically combine. In this case, yeah, they are going to chemically combine, but as the very start of the chapter tells you, that this entire chemical combination is going to happen by the transfer of electrons. That is exactly correct. What
Mm.
you can see in front of you in the diagram, that you are going to see a metal combining with a non-metal, right?
Yeah.
And then you are going to get the ionic compound. That's exactly what this whole thing is about.
Mm.
Remember that in ionic compound, the examples are going to be always like this: metal combining with a non-metal, forming an ionic compound. And the way that is going to happen, since we are mentioning specifically happens by the transfer of electrons, so that's going to happen like this. Electrons are going to be transferred from the metals to the
Mm.
non-metals.
Okay.
All right. So that's how electrons are going to get transferred to. So keep in mind, every time metal is going to lose electrons, non-metal is going to gain electrons, and
Yeah.
that's how metal and non-metal will combine to form an ionic compound. So that's how the transfer will occur,
What
right?
about the sign? Like when the metal loses electrons, the sign will be negative or it becomes positive.
It becomes positive. Why is it
Yeah.
positive? I'm going to explain that in the diagram,
Yeah,
since it's
that's
easier to understand that way,
yeah, yeah. Okay.
right? So I'm
Yeah.
gonna move ahead and okay, so ionic bonding, best known example, sodium chloride, that is ionic bonding. There are many other examples, but you can recognize ionic bonding because they usually contain a metal and a non-metal. There are a few uh, uh, examples, or you can say exceptions, in which the ionic compound would be made up of all non-metals, but mostly they would be containing metals. These are the only two exceptions at this level that we discussed about. There are
Yeah.
a couple of others too. Let's stick with these for now. So what happens is that when a metal and a non-metal combine, these diagrams are going to help us understand the answer to your question, why the signs plus and minus. You must be asking why we have a plus over here and a minus over here,
Mm.
right? If it's losing electrons, why are we putting a plus? If it's gaining electrons, why are we putting on a minus? The loss should be shown with something being subtracted, and the gain should be shown with something being added. Yeah, that I understand is the confusing part, but I'm gonna explain it real soon. But let's start with the basics. A metal gives an electron to a non-metal.
Mm.
This is the complete transfer of electron from, and this only happens from the outer shell of the metal to the outer shell of the non-metal. Remember, only outer or valence shells are actually experience a transfer of electron. No inner shells will do the same.
Yeah.
All right. So nothing is happening to the inner shell. Now, because the electron has a negative charge, so when something gains an electron, it becomes negatively charged. That is something which definitely requires an explanation, and this key point explains it as a whole. Now, let me explain that over here in terms of simple mathematics. Now, sodium has a proton number of 11.
Mm.
That means it has protons, 11 protons, and that means it has 11 electrons. Now, since every proton has a plus one charge, 11 protons would have plus 11 charge, and
Mm.
11 electrons would have negative 11 charge. So the entire atom would have plus 11 minus 11 equal to what charge? Zero.
Mm.
But when it loses an electron, what happens is that we're going to take this electron and we're going to give it away to chlorine. As you can see, there is no outer shell electron over here. Instead, we have red colored electron over here, which
Yeah.
means out of 11, you lost one electron. So when it is converted into sodium ion, this form, which we show with the positive, why positive? Because now the protons are 11, but the electrons are 10.
Yeah.
So the total positive charge on protons would be plus 11, the total negative charge would be minus 10. So go with the simple mathematics as I did over here, plus 11 minus 10 is equal to plus 1. And that
Hmm.
plus 1 is shown over here.
Oh, okay.
All right. I'm going to
Yeah.
do the same mathematics for chlorine atom. Now, chlorine has an atomic number of 17, which
Hmm.
means it has 17 protons in its atom and 17 electrons in its atom. So it's plus 17 and it's minus 17, and you can cancel them out to get your answer 0. But when we talk about a chloride ion, take a look. Apart from its 17 electrons, there is one extra electron it has that comes from sodium. So the number of protons are equal to 17, but the number of electrons are equal to 18. This time it has a plus 17 and minus 18 charge, the answers to which is minus 1, and that minus 1 is shown over here.
Hmm.
Because plus 17 minus 18 equals to minus 1
Yeah.
in simple mathematics. And that exact minus 1 is shown over here. Simply speaking, electron has a negative charge. If something gains one electron, it would get minus one charge. If it gains two electrons, minus two charge. If it gains three electrons, minus three charge. If something loses one electron plus one charge, two electrons lost plus two charge, three electrons lost plus three charge. That's
Hmm.
as simple as it is.
Yeah.
All right.
Hmm.
So the charged particles are then called ions. We don't call them atoms. Remember, the very basic stuff about atom is that it has equal number of protons and electrons. Ions can never have equal number of protons and electrons. Ions always have an imbalance. Either they have more protons than electrons. If that happens, they have a positive charge. It has
Hmm.
more protons than it has electrons, hence a positive ion. And if it has more electrons than it has protons, then it is negatively charged. Again, it's an ion. It's a negative ion then.
Yeah.
So positive ion is called a cation, and a negative ion is called as an anion. Atoms can lose more than one electron. They may lose two electrons, they may lose three. In the similar way, they may gain two electrons, they may gain three. Then the charges are going to be different. All right.
Yeah.
But then they are always assumed as ions, and ions mean an imbalance of electrons and protons. How is ionic compound formed? Then the positive ions attract the negative ones, and they are actually arranged in an alternate manner like this, and they have very strong forces of attraction. The word we exactly use, the term we exactly use is the strong electrostatic attraction between positive and negative ions. When I use the word strong electrostatic, from electrostatic I mean between positively and negatively charged. Opposite charges attraction is known as electrostatic attraction.
Hmm.
Since ions have different charges and they had a positive charge, Cn had a negative charge, they can attract each other with electrostatic force of attraction, and that is one of the strongest forms of that attraction. Hence, ionic bond is a pretty strong bond. We usually show bonds with dot and cross diagrams. Dot and cross diagrams are actually easy to show on a piece of paper how two atoms are going to interact with one another. Now, since sodium chloride was the easiest of examples, sodium only loses one electron, chlorine only gains one electron, so it is actually the easiest of examples. There
Hmm.
is one more example in your book that tells you that more than one electron may be gained or lost. Take a look at this example, magnesium oxide. Magnesium loses two electrons, hence a plus two charge. Oxygen gains two electrons, hence a negative two charge.
Yeah.
And there are two arrows. Whenever you see these arrows, you would get to know that the head represents for something that is about to be converted into a negative ion or something that gains electrons. And the tail represents something that is about to lose electrons or to be converted into a positive ion.
Mm.
That's every time the convention is going to be. You are going to show the arrow from the electrons are lost to the atom that are electrons are gained. And that's way how the arrows are supposed to be every single time. Since this convention is followed by every student, teacher, researcher, or scientist on the planet. All right?
Yeah.
Okay. So we can form plus two or minus two ion. As soon as you see a plus two or a minus two ion, this immediately should give you the idea that the plus two ion lost two electrons, after which it was formed, of course, and the negative two ion shows the gain of two electrons. And notice, notice something very important. When we draw circles of the positive ion, usually number of circles are less than what we previously started off with. Notice we started off with one, two, and three circles, three shells, and now it has only two shells. Since the
Yeah.
outermost shell had only two electrons, when you take out those two electrons, the shell does not exist anymore. Hence two.
Yeah.
Not just that, notice for the negative ions case that in terms of negative ions, the outermost shell is always a mixture of dots and crosses. Take a look. These are not all dots, these are not all crosses. It actually is a mixture.
Mm.
There are two dots, which means the two electrons came from magnesium.
Yeah.
So a positive ion, usually one of the circles would be missing, would be disappearing after it loses electrons and forms a positive ion. But when the negative ion is formed, the outermost shell is usually complete, and that is actually a mixture of dots and crosses.
Mm.
This
Yeah.
is something we should observe, and we should do the same when we are asked to draw diagrams. Now, we come to a specific point. They try to attain, by they I mean atoms, they try to attain the nearest noble gas electronic configuration and bonding. And that's what we are going to explain from this specific example. Now notice aluminum is present in group 3. It has 3 electrons in its outermost shell. When
Yeah.
3 electrons are removed, it is converted to an Al plus 3 charged base ion.
Mm. Yeah.
Those electrons are added to nitrogen. It has 5 electrons in its outermost shell, and then we add 3 electrons in there. That becomes a mixture, and now it has a negative 3 charge.
Mm.
Take note, this specific electronic configuration can be mentioned as 2 electrons in the first shell and 8 electrons in the second shell. This specific electronic configuration, though it's a mixture of dots and crosses, can be explained as 2 electrons in the first shell and
It,
8 electrons in the second shell.
mm.
And actually, both of these electronic configurations represent what? They represent neon atom. And we have a specific word for that. If some things have equal number of electrons, same number of electrons, we call them isoelectronics. So sodium ion, neon, aluminum ion, nitride ion, sodium ion, neon, all four of them are isoelectronic. Can you see that from this page? This is
Mm.
2,8, this is
Yes.
2,8, this also is 2,8, this also is 2,8. So they all have same number of electronic configuration, which actually belongs to the neon's electronic configuration. We call them isoelectronic.
Yeah.
So you would notice that many ions tend to have the electronic configuration of nearest noble gas, which in this case is neon. Sodium tried to achieve that configuration, aluminum tried to achieve that configuration, nitrogen tried to achieve that configuration. So we can safely say, be it a positive ion or a negative ion, they try to achieve the nearest noble gases configuration. Why? Because those are the stable configurations. Stable as in, noble as in, which means that they have complete outermost electron shells. It's not complete, stable outermost electron shells with 8 electrons in the outermost shell, which means that they are now stable and they don't need to either lose electrons or gain electrons or share electrons anymore, which honestly means no more need for bonding.
Yeah.
All right.
Yeah.
So in every example earlier, although we haven't mentioned it, but you may notice that this and this also have the configuration of 2 and 8, neon's configuration. This has 2 8 configuration neon. This has 2 8, which means it's isoelectric to neon, but this has 2 8 8 configuration, which is isoelectronic to argon. All right.
Yeah.
You can always match this configuration with any of the noble gases configuration, and you will always come up with the answer which one does this matches to. So when I compare to 8, it matches to neon. When I compare to 8 8, it matches to argon. Right?
Yep.
Since you have the copy of periodic table along with this whole question paper, so it's easier for students to match what electronic configuration are they obtaining, or which specific noble gas electronic configuration are they obtaining. All right. He's giving more examples in these lines. He's talking about rubidium going forth with the electronic configuration of krypton, or iodine going forth with the electronic configuration of xenon. So that's possible. But there are some ions which do not go with the electronic configuration of nearest global noble gases. We're not going to do them in IGCSE since it's pretty much strongly mentioned over here. This one definitely is not a noble gas. It's not mentioned. So this is not going to be a part of your syllabus.
Mm.
And let me tell you, most of these are transition elements. All right.
Yeah.
Okay. So moving on. Some other examples of ionic bonding. Sorry. Lithium fluoride, one electron transferred from lithium to fluorine. That's how the electron ionic bond forms. I think this is pretty easy of an example.
Yep.
They're specifically going with this example because they want to tell you how one electron is transferred from one atom to another. This actually is an easier example, but as they actually want to step up to more difficult examples at the bottom of this page, take a look. Now, this time we have an example, calcium chloride, and you're going to notice that a single individual calcium atom is being converted into an ion, but when it donates both, actually not donates, loses both of its electrons to separate chlorine atom. One electron is given to a separate chlorine atom, the other one to a separate one. So since calcium loses 2 electrons and is converted to an calcium ion, each of the electron is gained by an individual chloride ion atom to form an ion actually. All right. So how do we represent this in a formula? Take a look. This is the formula of calcium chloride as mentioned over here. Now it's pretty easy to see from the formula that we only have one calcium atom, but we have two chlorine atoms in this formula. So of course, one calcium atom will be converted into one calcium ion after losing electrons to each of the chlorine atoms, which are then converted into chloride ions. Make sense?
Yes.
So also, this had the electronic configuration of 2882, but as soon as it lost its electron, the electronic configuration went down to 288. And now this one is isoelectronic to argon.
Mm.
Now this
Yeah.
had the electronic configuration of 288, but previously it started with 287. This also started off with 287, and later on it went to 288. All right, makes sense.
Yeah.
So Any questions from this diagram, or can we move on?
We can move on.
Okay, good, great. Formula for ionic compounds. There are so many different ionic compounds that you're going to encounter that it's impossible to learn all their formulae. So we need a simple working to work out how their formulae are going to be. So we need a very simple shortcut method, and that's what we're going to learn on the next page. Usually when we talk about ions, ions are formed from atoms, a group of atoms. But actually the formation of ions is all about loss of electron or gain of electron. Now, electrons carry a negative charge. So whenever the atoms are going to lose or gain electrons, they will either form positive ions or they'll form negative ions. Compounds are electrically neutral, which means that by the end of the compound formation, everything, every charge must have been balanced out. And that's a great thing. We need to understand how we balance out the charges. Now, there are two ways to work that out. One of which is given in the book. We're going to discuss the second one right after. Okay,
Yeah.
if you look at these groups in the periodic table, these are the charges on the ions. All right, there are some examples. So it's pretty easy that if you remember along with the group what charge it's going to have, you can cover most of the elements of the periodic table. Easy enough?
No, I didn't understand.
Okay. All the elements in group 1 are going to have plus 1 charge, means they're always going to lose 1 electron.
Yeah.
Elements in group 2 are always going to lose 2 electrons, so always a plus 2 charge. Group 3 plus 3 means loss of 3 electrons. Group 5 gain of 3 electrons, so every time minus 3. Group 6 gain of 2 electrons, so every time minus 2, and then gain of 1. So loss of 1 electron, loss of 2 electrons. That's why this charge, loss of 3 electrons. It is going to gain 3 electrons then. It is going to gain 2 electrons then. And that makes sense. It is going to gain 1 electron then. Remember, they are all trying to gain or lose electrons to get to the nearest noble gas configuration and have 8 electrons in their outermost shell. So something
Mm.
that has 7 electrons will gain 1 to have 8 electrons. Something if has 2 electrons in their outermost shell, it's understood it's going to gain 2 to make a total of 8 electrons. Something is going to have 5 electrons in its outermost shell. It's obvious that they're going to go for a gain of 3 electrons to have 8 electrons in their outermost shell to balance out their entire structure, right? To get stable. That's what this means. But still, we need a practice. So we're going to go for a practice right away. These are some examples, so I'm going to go with these examples. So as soon as you see a magnesium atom and an oxygen atom,
Mm.
you'd understand that magnesium actually belongs to group 2. So when it forms an ion, the ion would be plus 2. Now you know.
Yeah.
You're going to remember these, and automatically these signs will be the ones that you'll get at the answer. All right. Since magnesium is present in group 2 in the periodic table, it's going to lose 2 electrons and form a plus 2 ion. Since oxygen is present in group 6 gain 2 electrons, so it's going to form a negative 2 ion.
Mm.
What would be the formula? 2 plus and 2 minus actually balance one another, and the answer is 0. So we can simply combine these two to form NTO. No need for any numbers.
Okay.
That's what the charges on an ion and balancing the whole thing out means. Make sense? You need to
Yeah.
turn the entire thing into 0. Okay, let's take one more example. So I'm going to erase all of these. And since this was a pretty easy of an example, I'm going to take a somewhat different example. Let's assume we have sodium from group 1 and nitrogen from group 5.
Mm.
Now, since sodium is from group 1, it is going to lose one electron from a plus sign. So of course this is converted into sodium Na positive. For nitrogen, it belongs to group 5. It is going to gain 3 electrons, have a -3 charge. So of course it is going to form N negative 3. Now +1 -3 are not equal to 0. They are not.
Mm.
So you need a change. What kind of change do you need? If you have 3 of these, only then this sign can be converted into equal. Make sense? I'm going to
Mm.
go for simple mathematics. That's actually simple mathematics. So if we have 3 of these ions, we can work out the whole thing. So Na and N can be written together if we have 3 Na. There you go. You have the formula.
Mm. Yeah, okay.
Okay. But since your book gives you this method, so we say that this method is something that you cannot. Well, what I say is that I have somewhat a different but an easier method. Now,
Mm.
let's try my method. It's going to be a little bit different from this one. You're going to end up having the same thing, but okay. So, sodium and nitrogen. Now, you already know this is going to be converted into +1, and this is going to be converted into -3, right?
Yeah.
We already know that. Now, from here on onwards, the steps are a little different. What we're going to do is that we're going to complete this number, and I'm going to move this number to the bottom of nitrogen and this number to the bottom of sodium.
Mm.
But when I'm going to write the numbers at their bottom, I'm not going to write the signs along with them. And since we never mention 1 at the bottom, this boils down to, there you go. This method, I think, is pretty great. This method, what I think is that this method's easier. Just
Yeah.
switch the numbers and don't write the signs. As easy as that. Balancing the whole thing mathematically may be a very sound idea, but sometimes I've seen students not being able to pick that idea in the first go, especially the ones that are not good with math. All right. You may or
Yeah.
may not be good with math. That's not the point. The point is that I personally find this step or this idea easier than the previous one.
Mm. Yes.
Okay. Let's take
Mm.
another example. All right. You have aluminum and you have oxygen. Now, from these set of examples, you already know that aluminum is converted into Al plus 3, and you already know that oxygen is converted into Al minus 2. You're going to move this entire state to the bottom of oxygen, this entire state to the bottom of aluminum, but you're going to write them without the signs, pluses or minuses. There you go. You have the formula. Pretty
Mm.
easy.
Yeah. Can you give me one? I want to do it myself.
Yeah, I want to tell you one more trick before you get started with your examples. So,
Yeah.
there is one small trick in there if you have similar numbers. That is, let's start with the example that we first did. Magnesium is converted into Mg positive 2 ion from this one to plus. This one is converted into negative 2 ion, this one. Now, in this case, when you have similar numbers and you end up having 2 and 2, what you're supposed to do is to simplify. Since both the numbers are 2, you can divide both the numbers. So they are going to be converted into 1 and 1. Divide both the numbers by 2. Since we never mentioned ones, so MgO.
Yeah. Okay.
So you need to add a simplification step. You need to simplify them if the numbers are same or if the numbers are divisible by a single number. If both the numbers are divisible by a single number, then you need to simplify. So this method is good, but this method is tricky when it comes to same numbers or numbers that are divisible by one another.
if the numbers are same, we should just like simplify, and then when it ends up being one, you should just write the formula without writing one, right?
Exactly.
Yeah. Okay.
All right.
Yes.
So these are just examples from the group. Now we're going to pick different atoms. So what I'm going to do is that I'm going to go to the periodic table page and we're going to solve a few questions over there. All right. So I'm going to erase all of this stuff. What I usually do with my students is that I ask them to write the state. So I'm going to do it like this. It's much faster that way. It's much faster to move in between the pages this way. All right, great. Now you have the entire periodic table in front of you. So what I tell my students is that what they can do is that they can write the states on top of the periodic table. This is group one. All of these elements are going to show you plus one state. This is group two. All elements of this group from top to bottom are going to show you plus two state. These plus three, these minus three, these minus two, these minus one. All right. This
Yeah.
is what these groups mean. Okay. So we're going to solve some examples. I am going to erase all of this. Okay, since this one is not written in a good way. Minus 3, minus 2, minus 1. This is group 0. This does not show a state. And all of these go for covalent bonding. They tend not to go with ionic bonding. So we're not going to consider anything from group 4. So we have eliminated transition elements. We have eliminated these elements as well, right? We're not going to do them. Just these three groups and these three groups. That's about it. That's
Mm.
where the examples for ionic bondings are going to lie. So I want you to go ahead and form a compound from potassium and iodine. Now try locating the elements first, then come up with their states, and then cross multiply and get the answers. I
Yeah.
am also going to allow you to annotate on my screen if you want to.
Yeah, sure, but let me solve it first, and then I will do it in your
Yeah,
screen.
sure. Take your time. I don't mind. It's not
Yeah.
mandatory.
Yeah. Okay. Yeah, I'm done.
All right, continue. You may tell me that orally, you may annotate it on the board. It's entirely
No,
up to you.
I will say orally because if I do it on the board, I'm not using mouse, so my handwriting
Yeah,
won't come.
that's fine. That's fine. Go ahead.
Yeah. Okay. So
First
let
things first, the charge is on the ions. So what charge would potassium ion have?
So, potassium have +1.
Great. So I'm going to write potassium as +1. What about iodine?
Iodine have -1.
So iodine is converted into iodide ion, which has a -1 charge. So
Yeah.
I'm going to move this one to over here and this one over here. What happens after?
So it'll be K1
Mm-hmm.
and I1. As we
Mm-hmm.
don't count ones, so it'll be K and I.
Ki. Perfect.
Yeah.
All right. Let's go with another example. This time you are going to work between calcium and bromine, Br.
Okay. Yeah, done.
Okay, so calcium has a charge of
+2, +2.
great, and bromine is converted into bromide ion, which has a charge of
-1.
-1, right? And then after cross multiplication, this becomes
Um, it'll be calcium will be Ca1
right.
and bromine will be 2.
So since we do not write ones, this would become
So it'll be CaBr2. Yeah.
perfect. I just erased one, right?
Yeah.
So
Yes.
that's great. We'll move on. Okay, this time it's going to be
The same one.
no. At this time it's going to be Ba and N,
Okay.
barium and nitrogen.
Okay. Yeah, done.
All right. So barium has a charge of
+2.
great, nitrogen
-3.
-3. After moving, the compound become
Ba3N2.
perfect. And there is no simplification required,
Yeah.
right? Now I
Yes.
want you to go ahead and work with Sr and S.
Okay. Okay, done.
And that is
Okay,
Sr
so
or strontium has
okay, Sr has the charge of +2,
+2,
and S has -2.
-2. So
Then
afterwards,
after changing, I mean multiplying, we get Sr2 and Sr2.
Sr2S2.
S2, sorry. And now we will simplify. So it will be 1. So we don't count 1. So it will be SRS.
Right, great. Now you know. Now, just to make the question more difficult, I'm going to pick atoms out of this. When that's going to
Mm.
happen, they're going to tell you which state they have. For example, I'm going to pick this iron atom, and I'm informing you first that this one is +3.
Mm.
And then this reacts with sulfur, and sulfur, since you just solved sulfur, you know that's -2. So what kind of ion are they going to form then?
Okay, let me do.
Sure, take your time.
Is it Fe2 and S3?
Perfect. The answer would be Fe2S3. Great.
Yeah.
So they may pick an atom from here, but when that happens, they're going to tell you what state it's going to get to, or what exactly is going to be the charge on top of it.
Yeah.
All right. So now you know how to convert them. Since it's above